All right, so we are starting Unit 4. Unit 4 is all on probability. So we're going to start off with permutations and combinations. All right, permutations and combinations are just a way to find the different ways that things can be arranged. All right, start off with the fundamental counting principle. All right, that just basically says if event number 1 can occur in X number of ways and event number 2 can occur in Y number of ways, then the number of ways that X and Y can occur together is X times Y. So you're multiplying the numbers. All right, so it looks like this. All right, example 1. In Maryland 2004, the license plates consisted of 3 letters followed by 3 numbers. All right, how many different license plates could they make? All right, so 3 letters, so we could have something like A, B, C, and then 3 numbers. So 1, 6, 8. All right, so that could be a license plate. All right, that could be one. All right, also, we could have had something like this. We could have A, 0, 0, 0. So that could be another license plate. All right. So we have to figure out how many different license plates they could make. Well, we look at the choice number 1, which is the letter. So how many different choices do they have? Well, 26. So they have 26 choices for first one. All right. And then B, all right, another letter. So there's still 26 different letters. All right. And then C, 26 different letters. All right. And then we have numbers. So now numbers are 10. So they can be 0 through 9. So we have times 10. All right. And then another number times 10. And then times 10. All right. So now to find out how many different license plates they can make, all we have to do is multiply all those things together. All right. So looks like this. 26 times 26 times 26 times 10 times 10 times 10. Just make sure I had it in all right. Okay. And enter. All right. So we got that they could make 17,576,000 different license plates. All right. That's how many different license plates they can make. All right. In Maryland in 1912, the license plates consisted of 4 numbers. How many different license plates could they make? So they could have a license plate that was 0001. All right. They could have one that was 4836. All right. So it's the different license plates that they had. Consisted just of 4 numbers. All right. So again, for the first number, 10 different possibilities. Second one, 10, 10, and 10. So I need a 1 and 1, 2, 3, 4 zeros. So 10,000 different license plates that they can make. All right. So you can do the U-Try, and if you have questions on it, you can send me your questions. All right. All right. So now we're going to get on to permutations. All right. Permutations. The number of permutations of n items taken r at a time is given by this formula. So this is our formula for permutations. N, little n, big P, little r. Now, n factorial. That means you take that number and you multiply it. So, because these are on the homework, you would have something like, I might give you something like 3 factorial. 3 factorial is equal to 3 times 2 times 1, which is 6. All right, so again, 3 factorial means you start at that number, you multiply them all the way down to 1, and you get your answer. All right, so that's what that factorial means. So it's n factorial over n minus r factorial. So the number out front is the n, the number in the back is the r. All right, now, when we use permutations, this is important because it's the way you got to figure out whether you're using permutations or combinations. Order matters. That means if you change the order, you would get a different arrangement. All right, so order is important there. All right, so here's an example of a permutations problem. There are 8 people running a race. How many different ways can they finish first, second, and third? Okay, so we have 8 people running a race. P, all right, that's the total number. It goes up front, that's n. And R is how many of them you're taking at a time. Well, first, second, and third, so that's 3. So 8p3, all right, is what it looks like. So we use our formula. It's going to be 8 factorial over 8 minus 3 factorial. All right, so I'm going to show you an easy way to do this formula. So in the bottom, we have 8 minus 3, which is 5. So we're going to have 8 factorial over 5 factorial. So we can write 8 factorial as 8 times 7 times 6 times 5 factorial, because we have a 5 factorial in the bottom, and they're just going to cancel out. All right, so I get my answer is 8 times 7 times 6, and I get 336. So there's going to be 336 different ways we can award a first, second, and third place. Okay? All right, then you have 2 U-tries for you to do. So you can go ahead and you can do those. And again, if you have questions, just send me a question and I can answer them. All right, combinations. Here we go. Here's our combinations formula. Combinations, now we got a C in the middle, so it's NCR. It's n factorial over r factorial times n minus r factorial. Okay, so the only difference here is now they're putting an r factorial in the bottom. Now, this is when order does not matter. All right, if you change the order, it's not going to give you something new. Okay, so here's an example of this. All right, Mr. Marley's has broken his group up into 10 different groups, or his students up into 10 different groups. They had to create a poster to represent the Battle of Pearl Harbor, and he will select the best 4 posters to display and award 3 points to all the students in the winning groups. In how many ways can he select the best poster? All right. So the reason this is a combination problem is it doesn't matter how he picks them. They're all going to have their poster displayed, and they're all going to get the bonus points. So it doesn't matter if they come in first, second, or third, they're going to get the same exact thing. So order doesn't matter. So we have 10 different groups. And again, it's C because order doesn't matter. And he's selecting 4 posters. So it's C4. All right, so our formula again. N, which is 10, factorial, over R, which is 4 factorial, over, or times, N, which is 10, minus R, which is 4, factorial. All right, so in the top, well, we got 10 factorial over 4 factorial, and then 6 factorial. So now the 10 factorial, 10 times 9 times 8 times 7 times 6 factorial over 4 factorial, 4 times 3 times 2 times 1, 6 factorial. I'm just going to leave it because these are going to cancel out. So now I got 10 times 9 times 8 divided by 4 times 3 times 2. All right, so here we can do that. We can do 10 times 9 times 8 times 7, enter. And then I'll divide that by, and I'll put a parenthesis and do 4 times 3 times 2 times 1 if you want to put it in there, and hit enter, and I get 210. So there's 210 different ways he can award them points. All right, and then you have 2 U-tries to do. All right, and then we got example 4. Example 4, you have to determine if this is, just determine if it's combinations or permutations. All right, so let's think about this. Jenny's playing with 7 different colored squares. Pink, yellow, orange, blue, purple, green, and red. How many different ways can she place that 3 of them side by side to form patterns? All right, is this combinations or is this permutations? All right, now I think it's going to be permutations because order does matter. For instance, if I had a pink, a yellow, and a blue tile side by side, well, that would be different than having a blue, a pink, and a yellow tile. it would be a different pattern, or it would be a different than having a yellow, a pink, and a blue. All right, so order matters because it's going to make me a different pattern. So this problem, permutations. All right, because again, order matters. All right, Charlie's in charge of making 6 kickball teams to play in a tournament for the junior class challenge. How many different teams can be formed if there are 30 juniors to choose from? And again, we're not figuring this out. All we're doing is deciding if it's going to be permutations or combinations. This one, as long as all the players are equal, as long as he's not going to put them in positions, then this one is a combinations. Because order doesn't matter. He's just picking people and putting them on teams. All right. C, this one, you create a song mix of 7 songs for your party. You have 32 different songs to choose from. How many different mixes can you create? Now, this one, it all depends on the songs you have in there. If you have a mixture of songs, then this one may be a permutations problem. All right? So I'm going to say permutations if songs are different types. All right? But it could be also thought of as a combinations if the songs are all the same type. And by type, I mean by they're all rock songs or something like that, or they're all country songs, or they're all rap, or they're all dance songs. So, again, it all depends how you look at that. Okay? And that is it for the notes. So your homework is going to be the class work for combinations and permutations.